Hello, welcome to the presentation about automated visualization of funding dispersion. This was my project for Smart India Hackathon 2017, under Ministry of Rural Development. My problem statement is real-time visualization of location-wise financial transactions, volume and amount, for various schemes such as PMAY, Gramin, MGNREGS, PMGSY, NRLM, DDU, GKY. As part of various rural development schemes, financial support is provided to beneficiary in which funds are transferred to various beneficiaries. Some locations or areas have high transactions, volume, amount, and some have low financial transactions recorded. An automated system is required which can act as repository for all information and visualize location-wise transactions happening. This would help the MORD, DFS, bank/FIS etc., participating stakeholders in schemes, to visualize the level of transactional load area-wise and help them in making location-specific decisions, such as installing branches, ATMs, BCS in areas with low penetration having large transaction volumes. Let's look at the algorithm. So, for visualization of area-wise load, first we must determine a formula to find out load. According to my algorithm, load can be defined as work done divided by work which should have been done. We can clearly see that as the work done increases, the load increases, and as the work which should have been done decreases, our load increases. Now, while calculating the work done, we need to look at four factors, which are 1. Know of beneficiaries coming in the bank. 2. Area covered by the bank. 3. Employees working in the bank. 4. Working hours and days of the bank. Using these factors we formulate the work done as shown. Here the total work done can be defined as summation FO work done for each bank from 1 to n, where n is number of banks present in the given area, which is calculated by the given formula. Now to calculate load, we must compare the total work done with work which should have been done, which is calculated from the give formula. Let's look at the example of village named Technopur. Technopur is divided into 4 sectors, 3 of these sectors have financial institutions. According to my algorithm, the stress for particular area is calculated. So let's apply the algorithm to Technopur. This is the data for 3 banks of Technopur, which are Sector 1 Bank, Sector 2 Bank, and Sector 3 Bank respectively. These banks were open for 15 days this month, excluding all the bank holidays and weekends. But the working number of beneficiaries for 3 banks are 50, 40 and 30 respectively. Also the banks were open for 6 hours, 7 hours, and 6 hours respectively. All the data is given. And number of employees working for the bank is 10, 8, and 6 respectively. According to this data, work done by the single bank is calculated, and for total work done for all the banks is added. After that, number of beneficiaries for particular area is added and it is divided by the number of financial institutions in the area. This give us work which should have been done. We divide work done with work which should have been done, to get load. Now the law states that, in the end of the month, when each beneficiary is paid, the load must be 0. To achieve this, the employees had to work 0.30575 times more than they were supposed to, hence load is 0.30575. Working 0.30571 times more is not much, hence the load here is moderate. But as soon as it goes above 1, the conditions become difficult, and hence, we can clearly see there needs to be an extra bank present in that particular area. Let's go back to the example of Technopur again. We saw there were originally 4 sectors, from which only 3 sectors had banks present in them. Let's divide Sector 4 in 2 parts. People from part close to Sector 1 will go to Sector 1 Bank. And people from part close to Sector 3 will go to Sector 3 Bank. So now we are presented with new data, which is as shown. We can clearly see that as the number of beneficiaries and area increases, the load increases.